Welcome student in this topic dielectric and electric polarization, which is from the chapter Electrostatic Potential and Capacitance. So let us see the topic dielectric materials. What are the dielectric materials is? The materials which don't allow the electric charges to pass through them are called dielectrics or dielectric materials. There are two types of a dielectric substance, which first one are a polar and the other non-polar substances. For example, dry air, dry wood, mica, paraffin, wax, etc. These are the examples of a dielectric substance. Now, polar substances are a substance which is made of a polar molecules are known as a polar substance. For example, HCl, H2O, NH3, CO2, alcohol. So hydrochloric acid, water, ammonia, carbon dioxide, alcohol. These are the example of polar substances. In polar substances, the positive charges center and their negative charges center do not coincide in the absence of the electric field. Polar molecules has a permanent electric dipole or dipole moment of its own and oriented randomly in the absence of electric or external field. When an electric field is applied on the dipole, it experiences a torque that tends to align the molecules along the direction of the applied electric field, giving surface layer at the positive and negative charges. We have another which is a non-polar substance. A substance made up of a non-polar molecules is known as non-polar substance. In the polar we studied the substance which is made up of a polar molecule, and in the non-polar we studied a substance which is made up of a non-polar molecules. Examples of a non-polar molecules are N2, O2, H2, CO2, methane, C6S6. In non-polar substances, the positive charges center and negative charges center. They are coincide with each other. If I am just taking about the polar molecules, so polar they do not coincide, and in the case of a non-polar, they are coincide. So in the non-polar molecules, they have a zero dipole moment of S, whereas polar they have a dipole moment. Polarizability. It is a ratio of induced electric dipole moment, which is a vector P, and applied electric field. That means polarizability will be the vector P divided by vector E. What is the polarization of a dielectric substance? Polarization of the dielectric substance is the process of inducing equal and opposite charges on the two opposite faces of the dielectric on application of electric field. Net charge or net electrostatic field in the dielectric substance due to the applied electric field. So let applied electric field E naught and electric field due to the polarization will be EP. Then E naught is equals to sigma by epsilon naught. EP is equals to sigma P divided by epsilon naught. But we know that if we just take a field, I'm just elaborating these things more. So if we have a field, two fields, first one is a positive, second one is a negative. If I just placed a dipole over there, this will be positive, this will be negative. There will be unnecessary movement will be start because they will be repel each other. If I just these two particular charges, so because of that they have because of induction they have their own electric field will be produced. Like this will be positive, so here this will be a negative and this will be a positive. So the direction of electric field lines like this EP, and for the direction of actual field lines that is a E naught. So if I'm just taking overall the electric field which is present in the surface, so E will be E naught because this is a very like magnitude in the very big amount of the magnitude minus EP. We always minus from the higher to the lower. If I just put all these value over there, so we get the result. E is equals to 1 by epsilon naught sigma minus sigma p. Here E is known as net electric field or reduce the value of electric field. Let's move with the some multiple choice questions. Charge carries in the conductors are holes, free electrons, ions, and none of these. The correct answer for this question is free electrons. Next, the center of a positive and negative charges are coincide, as you can see in the diagram also. Dipoles, polar molecules, non-polar molecules, and none of these. So the correct answer for this question is a non-polar molecule. Dielectric constant. Dielectric constant is represented as a capital K, the ratio of applied electric field intensity to the net electric field intensity on placing a dielectric between two opposite charge plates is called dielectric constant. What its physical mean? Simply mean is that if we just taking a particular field lines and want to place a dielectric, I just told you earlier what is dielectric. So because of that two poles, the dielectric experience some forces over there. Because of that some changes are happen, which is a generally. So that changes is disturbed or changed because of this dielectric constant. That means K is equals to E naught by E, the initial electric field, and the second one is electric field after placing the dielectric. So that will be gives the value of a K sigma divided by sigma minus sigma P. Sigma P is the actually polarization surface charge density. Here E is greater than E and K is always more than 1. Relation between surface charge density sigma and induced surface charge density sigma P. We know that net electric field intensity E is equals to E naught minus EP. This is the first equation. And from the earlier, we know E naught is equals to sigma by epsilon naught. So EP is equals to sigma P divided by epsilon naught. E is becomes sigma by epsilon naught times K, where K is the medium of a dielectric constant. I'm assuming as this is the equation number 2. So substituting the value of equation 2, which is in equation number 1, and get the result sigma by epsilon naught K is equals to sigma by epsilon naught minus sigma P by epsilon naught. So epsilon naught will be cut it out and the final result will come sigma P is equals to sigma minus sigma by K. That is sigma 1 minus 1 by K. This is the final result for the sigma P, which is sigma P is equals to K minus 1 divided by K times sigma. The next topic we have a polarization vector. The polarization vector measures the degree of a polarization. Means how much degree of the dipoles are changes during the couple of momentum or couple of moment. So it is defined as a dipole moment per unit volume of the polarized dielectric. P is equals to M by V. Susceptibility in dielectrics. So what is the meaning of a susceptibility? Susceptibility tells the nature of the medium. So dielectrics, that is the ratio of a magnitude of a polarizing vector to the magnitude of intensity of electric field. Again, keep in mind when we take the ratios, that will be tell again the things of the medium, that is the nature of the medium tells about the susceptibility. So dielectrics, polarization vector P is directly proportional to the intensity of electric field. That is the vector P is directly proportional to the vector E. If I just remove this proportionality sign, a constant will become in the nature, that is a chi epsilon naught, where chi is equals to vector P divided by epsilon naught times E in the dielectrics. If I just take the relationship between the chi and the K, so E is equals to E naught minus EP. If I just put the value of E naught over there, So we get the result of E naught, E plus sigma P divided by epsilon naught. But sigma P is equals to P over there. So I'll just use all these particular terms and get the result. E naught by E is equals to 1 plus chi, or K is equals to 1 plus chi. Here K is denoted for the kappa. We are saying as a kappa. So since the K is equals to epsilon naught divided by E, now we are just taking ahead with some numerical point of the MCQ. So dielectric constant K is equals to what? E naught divided by E, 1 plus chi, E divided by E naught, or both A and B. So the correct answer for this question is both A and B. Next we have an example of a dielectrics is, so mica, iron, copper, all of these. The answer is mica. So this is all about for the today's class. Wait for the next class. Till that, take care everyone.